Welcome to our podcast, where I, Keely Severson, Eric Johnson, and Alicia Swami are exposing mold. Today we are here with Dr. Nicolson. Dr. Nicolson on Gulf War syndrome, and I find that fascinating. Can you share a little bit about your work with us?
Well, I started working on this project after my stepdaughter returned from the Gulf War and became ill. And it turned out a lot of her colleagues were also ill, and so we got involved with various special forces and airborne units. My daughter served in the 101st Airborne Division. She was a crew chief on a Black Hawk helicopter and flew deep into Iraq with the deep insurgents during the conflict. And everything was fine until she came back and was in warrant officer school, actually, and her health started to fail. And she was training to be a pilot and couldn't pass the physical, so she eventually left the Army. It turned out okay for her because we helped her get over her illness and some of her colleagues as well. And she went on to medical school, and now she's a practicing neurologist in Kansas City. So it worked out for her, but for hundreds of thousands of other veterans, it didn't work out too well, including 50 or 60,000 that died because of the aftermath of the conflict. And these are numbers that you won't see anywhere. But we took quite a toll after that war. And so we were studying the illnesses from the Gulf War, and we published a few papers on that because they were really quite diverse. And we were very interested in a subset of those patients whose illness spread to immediate family members. So if the illness spread to immediate family members, it had to be contagious. There's no other way to explain it. At the time, the Department of Defense was trying to write this off as, well, maybe they were exposed to chemicals or something like that, brought back environmental hazards. But you really can't do that. When you come back, I mean, there's only really one way to spread illness to immediate family members, and that's really by a contagious infection. And so we started to look for various infections, and we ended up settling on 2 or 3 that we found. And one in particular that we found that about 40 to 45% of sick veterans, which turned out to be a mycoplasma. And to make a long story short, we now feel quite strongly that this mycoplasma was a contaminant in the military vaccines that the troops received during their deployment, because there were a number of instances where you could see that this was a real problem. For example, deployed personnel that were vaccinated, they showed a fairly high degree of Gulf War illness. 15% or so of the veterans that were deployed came down with Gulf War illness. But the ones who were deployed very quickly and didn't get vaccinated didn't become sick at all. And there were other indications. For example, there were some French forces, French officers that were deployed with the US units, and they didn't become sick with Gulf War illness. And they had the same exact exposures that the US forces had, and they didn't show any evidence of Gulf War illness. And then there were other coalition forces, Australians, British, who also received the same type of military vaccines, and they showed very high incidence of Gulf War illness. So what is Gulf War illness? Well, it's a collection of various types of illnesses, and no one event or cause can explain all the illnesses. But again, we were focusing on the illnesses that passed to immediate family members. And the most interesting were the children of these families, because they were becoming autistic at a very high frequency. And so they were showing autism spectrum disorders. And so we were very interested to find out what was causing this. So we started studying these families, and the veterans first, and then the family members. And we found that the unifying element of all this was infectious. And the most common infection found was a mycoplasma infection. I'm having a little trouble with the lighting here. Let me just adjust my camera here. There, that's better. So when we started studying this, we found that about 40 to 45% of the sick veterans, and certainly most of the immediate family members who became sick, the number was as high as 80%, had the same infection. So we thought that this infection, which turned out to be Mycoplasma, an unusual Mycoplasma at that, was something that was really not really very well known at the time. And the infection that we found, that we traced it down, was Mycoplasma fermentans, which is a very unusual infection. It was mostly worked on by the US Army. They published most of the papers on this type of infection. And in fact, the US Army pathologist held a patent on detecting this infection. So we thought that there was something here that was important, but there was a huge cover-up going on at the time. And of course, the VA and the DOD didn't like our results at all, and we were publishing our studies, and they really hated that because we had a number of peer-reviewed publications on this. And so it went on for a number of years, and so we tried to figure out what was the best way to treat these types of infections, because they were relatively unknown before the Gulf War. And then it started to get very unusual, because I was at the department chairman at the University of Texas MD Anderson Cancer Center and a professor at the medical school in Houston. And so I had the resources to actually investigate this further. People were contacting me in Texas. They said, well, you know, there are a number of people that have very similar signs and symptoms of what you found in the Gulf War veterans, except they were never in the Gulf. And where are you interested in studying in? And I said, well, we're pretty well booked up, but we'll take a look. And it turns out these were state of Texas employees. So I was a state of Texas employee, so I felt obligated to investigate this a little further. And it turned out they were all employees of Texas prisons, and 2 or 3 prisons in particular. And these just happened to be prisons where the Department of Defense was running some clinical trials. And so that was a lead into there. And then our breakthrough was that the assistant warden on one of the big Texas prisons became sick, and his entire family became sick, and his children becoming autistic, and one was diagnosed with Lou Gehrig's disease, and she was a teenager, and that's incredibly unusual to have someone that young get diagnosed with amyotrophic lateral sclerosis, that's what it's a medical term. And so we started testing these folks, and we found out they had actually the same infection that we found in the Gulf War veterans, and that was really unusual. And the only link here was the Department of Defense. There was no other link. So this became a political disaster for me, because the Department of Defense started putting pressure on my employer to stop this research that we were doing. And so they threatened to close down my laboratory, and I had to go through various committees that were investigating to see if we had done anything wrong, or everything from the budget to did we misspend a penny here, a penny there, or did we make any mistakes in our laboratory procedures or safety procedures, or you name it. They were going after me from 5 or 6 different directions to try and stop this research and shut it down. But we continued, and we continued to publish our results, but it became more and more difficult to do that because of the pressure that I was under. And eventually this would result in my resigning my position and leaving and forming a nonprofit research institute so we could continue our work, because it was just becoming too difficult to get anything done under the pressures that I was under. So we continued on, and other folks started testing veterans, and we're finding the same things that we found. So that was good. We had some confirmation, and they published papers like we did on it. But still, the mainstream science was completely ignoring this, and the medical people completely ignored it as well, because things like Mycoplasma are very unusual infections, and Some people don't even consider them pathogenic, but they're clearly pathogenic. And so we started to slowly investigate this in more detail. And we found out that things like Mycoplasma are involved in a number of different infections, usually as co-infections. For example, Lyme disease, Mycoplasma is the most prominent co-infection in Lyme disease, and most people don't even know that. And these sort of pathogenic bacteria are present in a number of other infections. We found them in high frequency in, for example, chronic fatigue syndrome. And these are people who don't have any link to the Gulf War or military personnel at all. It just turns out that these types of infections are very common. And then there was a link that we started to pursue because the children of the Gulf War families who became autistic were all testing positive for Mycoplasma. And so we started a study in Northern California with some patient groups that I'd made contact with. So these are autism spectrum disorder support groups. And so they supplied a number of children that we could test, and in cooperation with clinical psychologists who would do the confirmation of the diagnosis of autism spectrum disorder. We did a study which we published in the Journal of Neurosciences Research, which is a very prominent journal in the neurosciences, where we looked at a number of children and these had these diagnoses of autistic spectrum disorders, and we found that Mycoplasma was present in the majority of them. And so these were in particular areas of California. I don't know how widespread this is, but I have a feeling that this is an infection that's often overlooked. For example, in neurodegenerative diseases, we did find it in ALS, as I mentioned. We started with this one patient in the Texas prison system, a family member. And so we started to examine a few other patients. In particular, we started with Gulf War veterans who came down with ALS. And this is kind of interesting because there was a very high spike in ALS in veterans, but they were all Gulf War veterans. They were all deployed to Kuwait and Saudi Arabia and so on, and were present during the war. And these veterans, 100% of them tested positive for Mycoplasma fermentans. And we even had a couple of British and one Australian who were all in this group who received the military vaccines. They came down with ALS, and they also had the infection. So we had virtually 100% in the veterans. So we thought, well, we should really start looking at some civilians. And we found that even in civilians, there was a fairly high frequency of this type of infection. The difference was that in the veterans of the Gulf War, there was only one exception to the finding that everyone had Mycoplasma fermentans. And there was one Australian who had Mycoplasma genitalium and came down with ALS and was positive for that infection. But in the civilian population, we saw all kinds of different Mycoplasma species. So they weren't limited to Mycoplasma fermentans. In fact, Mycoplasma pneumoniae was the most common infection. And that's what you see in Mycoplasma patients worldwide. This is a very common infection. It's seen widely in atypical pneumonia, particularly childhood atypical pneumonia. It's very common to find Mycoplasma pneumoniae, which is a very common respiratory infection. In fact, a lot of people just carry it as a part of their normal flora, and they don't become sick from it because it's constrained to their oral cavity and really does not get in their blood, which is what we feel is the break point. Those people who really become symptomatic and have some sort of disorder or disease are the ones who the Mycoplasma has penetrated into the blood and is spread around the various organs in the body. And those are the ones that show symptoms. If you just have it in your oral cavity, you're not going to show symptoms. It's just superficial. So there was a lot of confusion about this, of course, in the literature, and a lot of confusion among practitioners who treat patients with chronic illnesses. Most of them still don't recognize Mycoplasma as a problem, but there are quite a few of them now that do, particularly those that treat children, know that this is a pathogen that's present in atypical pneumonia patients of very high frequency, and they know it's very serious, and people have died of it. So in the Gulf War veterans that had this, they also had chemical exposures and other things, and they were quite sick, and many of them went on to die unless they received treatment for their Mycoplasma infections. And so we were able to save a number of those folks from having a lethal course of their disease by treating their Mycoplasma. That's not the only problem they had, but that was contributing certainly to their very, very severe disease situations. So the story, I've been retired for a number of years now, and I still am working on problems that are associated with this. In fact, my latest studies are really working with these lipid compounds, which are really glycerophospholipids, which are components of our membranes, all the membranes in our cells and our body. These are a principal component of the matrix of the membrane. So they're absolutely very essential. And these glycerophospholipids are very sensitive to oxidative damage, particularly by free radicals, because they have double bonds. So the carbon-carbon double bonds are very sensitive to free radical oxidation. And when that happens in membranes, it affects the matrix of the membrane, the fluidity of the membrane, and they take a hit in terms of their function. And we were principally interested in mitochondria because we find that this is a problem in literally all people that have a chronic illness have mitochondrial function problems. And in aging as well, people as they get older, they lose about half their mitochondrial function. And we can trace a lot of this back to what goes on in the mitochondrial membrane, and particularly the inability to maintain the intermembrane, transmembrane potential of the mitochondria, which is essential for production of ATP. So if you can think of mitochondria as a battery, and you can think of the membranes as the insulation for that battery, if the insulation goes bad, or if there's a leak in the insulation, then the battery runs down and there's no more energy produced by the battery. Well, you can think of that in terms of mitochondria. If the transmembrane potential of the inner membrane of the mitochondria is compromised, then the mitochondria can't produce ATP, because that difference across the membrane is used to drive the production of ATP. That's where the energy comes in, because the electron transport chain in mitochondria, as you can think of it as a proton pump. It pumps protons across the inner mitochondrial membrane. And then those protons are used to drive back across the membrane to generate ATP, to take the high energy and then turn it into ATP. So if the inner membrane of the mitochondria is compromised, and if there's any leakage at all, and the potential goes down, you can't maintain that chemical electrical potential across the membrane, you can't generate ATP. And that's what happens as we age. And it's related to the damage to the lipids and other molecules in the inner membrane, mainly by free radical oxidants. As we age, we actually accumulate this kind of damage, and that's why our mitochondria don't function as well when we get older. And also in diseases, virtually every chronic disease, this is a problem. It can be traced back to problems in mitochondrial function. It's not the only problem, but it is a major problem, because we can't get better from these chronic illnesses if we don't have the energy produced by our mitochondria to help our cells repair and also detoxify. All that detoxification and repair requires energy. Without that energy, it's just not going to happen. So one of the things I've been working on over the years, since my background originally was in membranes, the fluid mosaic membrane. I was the co-author on that really landmark publication, which for the first time identified the structure of membranes as a fluid lipid matrix with proteins intercalated into this fluid matrix and so on. So that became the basis for membranes, and I've went on to do a lot of studies on this. And I actually started out when I was a graduate student working on mitochondrial membranes. So it goes way, way back to the middle 1960s, actually. So after my long career working on membranes and later on working on various diseases associated with membrane damage, as well as infections. And again, we got involved in the infections because we were driven by that family event, which is my stepdaughter coming down with Gulf War illness. But by and large, we've stuck with membranes, and I've been really fascinated by the ability to repair membranes using various types of glycerophospholipids, which are the backbone or the matrix of the membrane. So we've come up with some formulations which require these glycerophospholipids and unsaturated, linked to unsaturated fatty acids to provide the structure for the membrane to maintain, in the case of mitochondria, transmembrane potential, but also in all the other cells as well. And more recently, we've been looking at nerve cell membranes because there the transmembrane potential of the plasma membrane is extremely important in determining whether membrane depolarization and nerve transmission occurs. And so we've been looking at pain, for example, which is very dependent upon nerve transmission. And we found that these glycerophospholipids can be used at a high concentration to put a dent into pain, particularly chronic pain and widespread pain is seen in fibromyalgia because they essentially repair the outer plasma membrane, and the glycerophospholipids complex with some of the membrane channels, like the calcium channels that are involved in membrane signaling, and help stabilize them. So there's less depolarization. And one of the things we found in a lot of patients with widespread pain is they have spontaneous depolarization of their pain receptors. Essentially, their nerves are firing when they shouldn't be firing. And one of the reasons is they can't maintain a resting potential of the transmembrane potential across the nerve membrane. And so their nerves get triggered very easily and repeatedly. And so by helping stabilize that, we can reduce pain. And that's exactly what we see with giving these natural supplements. Now, the important thing about these natural supplements, like the membrane supplements, is that these are very important molecules. And as humans, we've evolved with a system of transport of these molecules that we absolutely save these molecules. We try not to let them get destroyed in the gut or the intestine. We complex them, we bring them in, and we transport them to cells because they're very important to our well-being. And what we found in doing our various studies is that if we put enough of these lipids in, they actually get transported as little lipid globules or in lipoproteins or in cells in much higher amounts than would normally be transported. And there's actually a survival reason for this, and it probably goes back to when humans were hunter-gatherers, and we'd go out and we needed these molecules. We didn't know we needed them, but in fact we needed them to survive. And the main source was animal meat, because you'd have to eat so much in the way of wild plant life, for example. You couldn't get enough of these molecules in doing that. So we would supplement the diet by eating animals. And of course, you'd have to kill the animals to eat them, and they were hard to catch and so on. So early humans probably only caught animals once every so often. And so the ones that survived were the ones that were best capable of capturing all these important molecules when they ate those animals. And so they would get a bolus of these lipids all at once, and they'd have to capture as many of those lipids as possible for the long-term survival of the species. So we've evolved with this ability to transport large quantities of these, and that's the secret of getting these into cells and so on, is that when we give these things orally to patients, we usually give several grams at once, for example, and they'll take in 80, 90, or close to 100% of these lipids because we've evolved with the capacity to bring these things in. And this has all been studied by people who are experts in lipid transport, and they find that 80 to 90% of these lipids are taken in the small intestine within a few hours after ingestion, after they eat, for example, a high lipid meal. So we know that there's mechanisms to get these things in, and there's mechanisms to transport them to the cells, and often they go through the liver first, and so we have a massive system of taking in these lipids in the liver and then retransporting them out to sending them to various tissues and cells that need them. So we have the mechanisms to pick these things up from our gut, to transport them to cells where they're needed, and then to exchange them with molecules that have been oxidized by free radicals and so on and need to be replaced because they're no longer functional. So we have this system built in, and it turns out to operate on what's called a mass action or a bulk movement process. So that means the more you put in, the more it gets to the terminal site where it's needed. And so we've just increased over the years the amounts that we give to people, and they get more and more in, and we see more rapid responses and more rapid recovery of their mitochondrial function, and reduction in their signs and symptoms that are associated with mitochondrial function. So that's one of the things that we've been working on quite heavily. So what does this have to do with people that have been exposed toxically? And I'm working with this right now. In fact, I just finished a small pilot trial with veterans who were chemically exposed. And so these were mostly veterans who were exposed to petrochemicals at very high concentrations. They've been sick ever since. They can't get rid of these because they're deeply embedded in their system, and it's very hard to remove these very hydrophobic chemicals that are deeply embedded in the cells and in the tissues and in the organs. But what we found is by using higher concentrations of these glycerophospholipids, these will actually get in enough concentration in cells to start slowly partitioning out these chemicals. And then there's this slow process. It's a mass action bulk flow process where it slowly brings it out again. And then finally it's deposited back in the intestines and into the stool and is eliminated in the stool. So this is a very slow process. So we give these veterans over the span of 6 months about 5 or 6 grams of these glycerophospholipids per day, and we can slowly start to move their chemicals out in the process. So as you can imagine, this type of natural medicine is good not only for petrochemicals, but it's good for other hydrophobic molecules that get embedded deep into membranes and hydrophobic places in cells. And so you can think of things like mold toxins, for example, which are very hydrophobic and get partitioned into very hydrophobic areas of cells and tissues. And this removal, just hang on just a second, let me just turn this off here. Otherwise it's going to continue to ring. Sorry about that. So we've then thought about using this for a number of other things as well. People that were damaged not only by chemicals, but also by hydrophobic toxin molecules as well. So there are various things like heterotoxins and mold toxins and all kinds of bacterial toxins and other things that fall into this broad category of hydrophobic chemicals that are quite toxic and get partitioned into membranes and other things of cells and cause chronic illness, and are very difficult to remove and very difficult to neutralize when they're in there. So our aim has been not to neutralize or destroy these, but to mobilize them. So if we can't easily get in and target them, one of the things we can do naturally is put enough of these natural membrane lipids in to help mobilize them and then slowly remove them from their hydrophobic sites that they're hiding inside our cells and tissues. And then once they're mobilized, then they get naturally transported back out to the intestines and then eventually eliminated in the stool. So that's been our working hypothesis that we've been working under. We've been having some success. We started with petrochemical removal from veterans, and now we've decided that this could be used for all sorts of things. The benefit of using this type of natural medicine type of therapy is that it's totally safe. These are molecules that are already present in our cell membranes and our tissues. We're not adding a drug. We're not adding anything new. These are there already. All we're really doing is changing the balance. We're changing the amounts. And as these things go into cells, if they're in excess and they're not needed in the membranes, they're actually stored in cells in small lipid globules and lipid droplets and other things that are inside the cells. And these are such important molecules that our cells have evolved with the system to retain these molecules because they're so valuable to cells. But what we're simply doing is taking bulk membrane lipids and putting them into a system and using this as a conveyor belt to slowly remove things like chemicals and hydrophobic molecules through this natural system that we've evolved with to remove toxic molecules, but also to save these important molecules that we need for the function of mitochondria, the function of cells, the function of nerves, all these important uses that we need these molecules for. These are very important molecules, and that's why we've evolved with a system to save them, store them, and we can utilize that system with this very important limitation is that without this bulk flow process, we wouldn't have any of this. We just have this natural process that we've evolved with that allows the shuttling of these molecules from the gut into the small intestines mainly, into the lymph and circulatory system and through the liver sometimes, but into tissues, into cells, into the organelles of the cells where these molecules are needed. But also there's a system for removal of damaged molecules. And we had this system all along because that's how our damaged molecules are replaced in membranes through this process. All we're really doing is trying to game the system. We're trying to increase the concentrations of these molecules to see if we can drive them out, drive the damaged ones out, and in the process drive in the good molecules that are not oxidized, not free radical damaged, not turned into ethers and oxidants that are toxic, and remove them when it does happen. So that's the whole purpose behind this. And we've seen this in people. We've seen improvements in mitochondrial function in older folks, for example, that are more than 90 years old, start to lose their mitochondrial function. It actually decays slowly with time, but you really see it in people that are 80, 90 years old because they've lost about half their mitochondrial function. And their systems sort of slow down and they have a buildup of these damaged membrane molecules. And we've put in the high concentrations of the anti-factor lipids. It's a commercial product, it's called. And this slowly will remove those. And so we've seen mitochondrial function in 90-year-olds return to the levels of middle age. So we can also see that their quality of life improves. Using quality of life indicators, we can actually measure this in people that are older. We can measure their mitochondrial function. If we take a sample of blood, we can measure it in their leukocytes. We can see that their transmembrane potential is being restored, whereas normally it was, falling down to lower and lower levels and we're getting less ATP generation. Now we can up that transmembrane potential and they get mitochondrial function back. They're producing ATP at the levels that they weren't before. So this is translated into their quality of life because their activity levels go up, their fatigue levels go down, so they're living better lives. So we think it's a very good anti-aging approach. We think it's a good detoxification approach, at least for hydrophobic petrochemicals and natural toxins. And we think it's a good, healthy approach for a number of other reasons. For example, in practically every disease process, there's destruction of membranes, and so they have to be repaired and so on. So this is a good way to naturally replace that damage that's occurred during disease and during trauma. We find that it also improves people in terms of their mental acuity, in terms of their short-term memory, in terms of a variety of other parameters that people go through when their mitochondrial function goes down in their brains. So there's a lot of potential uses for this, and so we're having a lot of fun playing around with this in different types of disabilities and different types of chronic illnesses in different situations. So I've been primarily, my focus has been on veterans' illnesses, but there's so many other things that they can be used for. And from the veterans, we ended up working with the veterans' family members and with a number of other disease problems that they have. So we've ended up working with civilians that have fatiguing illnesses, that have chronic pain, for example, that have other types of problems that are associated with loss of mitochondrial function. So I think the good news about this is that it's incredibly safe. You could take 50 grams of this per day without showing any adverse symptoms, and those are published studies. We didn't do this. Other people have been studying lipids, have looked at this. The lipids that we use are all natural membrane lipids. We get a lot of ours from plants. We mix them in with other things. We don't use animal lipids, so there's no chance of animal contamination, viruses, and other things. So from our plant sources, we make these products that we have commercially. A couple of companies I consult for. I don't have a company myself. I'm a retired professor of pathology and laboratory medicine and professor of biochemistry. I don't really deal with those sorts of things, but the companies that sell these products are also having tremendous success in helping their customers with their health problems. So I think it's a tremendous asset to people to take these lipids. I take them daily myself. I'm on matter of fact, I have it right here. This is what I take every day. It's called Inti-Factor Patented Energy, and it's just one of the companies that produces these products. And I think that I'm doing better because of it. I think I have better mental issues. I think I'm deteriorating at a slower rate because of it. So I'm happy with it. My entire family is on this, and so they're happy with it. Other people that I interact with seem to be quite happy. So there are a number of particular uses. I think the anti-aging use is particularly important because as we age, we do lose mitochondrial function, and that goes with all our tissues, but particularly our brains, and our central nervous system decays because of loss of mitochondrial function. So it's very important there, particularly important there. So again, that's my story, and I'll be glad to answer your questions about it.
Yeah, I've read that Professor Luc Montagnier of the Pasteur Institute, the co-discoverer of HIV, or actually the real discoverer, if you consider that he probably came before Dr. Gallo.
Yeah, I consider him the real discoverer.
Yeah, he believes that Mycoplasma is an enabler for HIV, that without the presence of Mycoplasma, that you would probably not progress to full-blown AIDS. And just as you mentioned, that it doesn't have to be a particular species of Mycoplasma, but there must be a Mycoplasma.
Yeah, I think I've really, when I started to go through the literature and found those papers, that was kind of an aha moment for me. Because as a cofactor in Lyme disease, for example, and even in COVID-19, one of the things that we've sort of, and I published a paper on this recently, it was more of a speculation paper, but I think it's true because now the data is coming out that people that die of COVID-19, the ones that die quickly and have severe disease and are just deteriorate and die fairly rapidly are the ones that have mycoplasma as well. So it's an important cofection in a number of different diseases, and particularly those lethal diseases that we find in neurodegenerative diseases, for example, like Lou Gehrigs disease or ALS. We find there's a very high percentage of mycoplasma as a co-infection there. Those patients, the ones that deteriorate and die, are the ones that have mycoplasma, the ones that have a slow course of their disease, or that actually there's a few that recover from it. And we've had some younger patients that have actually recovered from Lou Gehrig's disease, which is highly unheard of, and neurologists don't believe it, but it's true. They're the ones that we've conquered the mycoplasma, and then they can hold the other problems in check that they have that's causing their bodies to progress to a lethal form of the disease. So we know that this is important in chronic illnesses, and there's several acute illnesses that we think it's very important and primarily as a co-infection. So if we take an illness like Lyme disease, for example, which has a number of different bacterial infections, the most common co-infection in Lyme disease is Mycoplasma. And most people that treat Lyme disease don't even know that. Most patients that have Lyme disease don't know that. You have to treat the Mycoplasma if you have Lyme disease, or you just won't recover from it. And so it's important. And I think in a number of these other chronic illnesses that have Mycoplasma as a co-infection, if you don't treat the Mycoplasma, it's our experience is you just won't recover. So it's important in that issue. Just as Montagnier found in AIDS, the HIV is insufficient by itself, and that's why there are plenty of people walking around with HIV virus. They never progress to AIDS. It turns out those people are Mycoplasma negative, and they're never going to progress because they need the Mycoplasma to cause full-blown AIDS. And so they could be HIV positive and lead a healthy life or normal life. And there's some pretty prominent people that fall in that category. So we know that this is a very important cofactor or co-infection in lethal diseases. And so that's what I kind of want to leave you with, is that they're very important chronic illnesses that have Mycoplasma as a co-infection. And you need to know about that, because if you have that, you're not going to recover until that's treated. So you're going to continue to be ill. But if you treat that, you've got a chance to recover at least. And so that's really my important message.
Well, the question that you brought up about Gulf War veterans coming back and transmitting the illness to their spouses, their significant others, to their families, raises the question of just how important of a cofactor is this? Is it absolutely critical in development of Gulf War syndrome?
Well, in that case, I don't think so, because there are a number of different Gulf War illnesses, as we like to call them, rather than Gulf War syndrome, because they are illnesses and they're a collection of illnesses. And the problem is that people got thrown into this category of Gulf War syndrome. And there are all these different Gulf War illnesses. And I've written reviews on this. And if you try to segment out partial out these different subsets of patients into various disease categories, some have chemical exposures as the main problems. Others have biologic exposures as the main problems. Others may have other issues as well. So it's not a simple sort of problem. And even the diagnosis is not simple. And you've had these broad diagnostic categories. The reason they're so broad is that there's so many different subsets of patients, I think, that fall into this broad category of Gulf War illnesses. But if we just take this portion of the 40 or so percent that have Mycoplasma infections, those are ones that we can actually treat if we treat the Mycoplasma infection. And most of those people will recover if the Mycoplasma infection is treated, but they won't recover if it's not treated. And that's the bottom line. So if you expand that to other types of illnesses, like Lyme disease, for example, now in our studies, and other people have found the same thing, co-infection with Mycoplasma is present in about 60 to 70% of Lyme patients. Those are the patients that are the most difficult to treat. Those are the most patients, those 60 to 70% that have Mycoplasma are the ones that have progressive disease. Those are the ones that are the sickest. Those are the ones that are hardest to treat, hardest, most difficult to get a successful recovery, and so on. So you need to recognize that if they have Mycoplasma as part of a collection of infections, you can't ignore it. You have to treat that along with the other infections. So Lyme is particularly difficult to treat, possibly because people were not taking more of a holistic approach on that, considering the number of different types of infections and their different sensitivities to different treatments. So there was no single treatment that was effective with Lyme disease. And again, it goes along with a number of different infections that have different types of treatments, approaches, and so on. And you've got to consider all these factors in a treatment regimen for Lyme disease. And so people have struggled with this, but the ones that are handled that way, where they deal with the different aspects of the disease and deal with the different types of infections and their treatments, are much better off than the ones where they just say, well, it's only Borrelia burgdorferi. Well, for one thing, it's not just Borrelia burgdorferi. There are other species of Borrelia and Lyme disease as well. But if you just concentrate on Borrelia, you're not going to solve the problem. You may solve it for a few patients, but you're not going to solve it for the overwhelming majority of patients that have all these other infections as well. So in that case, that's a particularly difficult disease because there's so many different co-infections. And deal with all these co-infections means you've got to try and balance and go back and forth depending upon what's the major issue in a given patient and how can they be treated and what's the best approach to treatment and so on. It's a real nightmare. But the people that are being carefully managed and all of their different infections are being managed are the most likely to eventually recover from Lyme disease. The ones that are not, and their practitioners are taking a narrow approach to it, they're not going to recover. It's just too many different infections to deal with. So if we look at chronic diseases in general, this is also a problem in chronic diseases in general, because what we found is that people that have severe chronic illness that never recover from it, in fact, with time, they seem to get worse, are the ones that collect chronic infections with time, as well as the primary insult that may have started their chronic disease process, may have started it rolling, may have started their downhill process of poor health. They tend to, because their immune systems are not operating effectively and their systems are not operating as effectively, they're susceptible to more and more of these chronic infections. And as they pick these things up and bring more of these infections on board, they get sicker and sicker, and it's difficult to treat them because they've got more infections. They're often not tested for these infections and so on. So it's a real nightmare for a number of these chronic illness patients. And so I think we have to take a broader view of chronic illness. We can't take too narrow a view of this. And we have various environmental exposures, we have various infectious exposures, we have other things that are happening as well, nutritional, for example, and other things. We've got to kind of be aware of all these things that are happening, particularly in individual patients. So we're not going to solve the problem of that individual patient. So it's just a warning sign for practitioners and patients that if you think you know what's going on with your chronic illness, you may not have the full picture. You may not know the full story. There are other things going on, and you have to be cognizant of those other things going on, or you just may not recover. Even if you have a very effective treatment program for a given type of insult, a given type of contamination, or a given type of infection, that may not be enough. You've got to take a broader view of these illnesses because they're often very complex. They didn't happen all at once. Usually these patients, they become sicker and sicker over time. And over time, those exposures, those infections, those other things that happen are important. And it's important to find out about them. So that's kind of the story I'd kind of like to leave you with, is that these diagnosis categories, particularly with chronic illness, are not so black and white, not so simple. There's various shades of gray. And there are various other things that can complicate them. And there are nutritional problems, there are infections problems, there are contamination problems, there are problems of environmental toxins. There are all kinds of these different things. And when they get in these different various combinations, they are difficult to diagnose. It's difficult to know what's going on in an individual patient, and it's very difficult to treat them because you can't just treat one thing. You've got to take a broad view and start considering that there are other things going on, and you've got to consider those other things, or those patients are just not going to recover. They may partially recover.
Exactly what Dr. Stephen Strauss of the NIH said back in 1986, that we have to take a broad view, cast a wide net, or we might be missing something. And yet, when you look at clusters, when you look at transmission of illness through a community, or in the case of Gulf War syndrome, somebody coming out of the Gulf War theater and managing to transmit that illness to someone else, you can't help but wonder, well, can we hone in on a primary cause here, something that is really making the difference? And it seemed that this had been done with Mycoplasma fermentans. And then
that was a special case. Let me just go back and say that was a unique situation. A unique situation because we had a group of very healthy individuals, primarily young, less than 25 years of age, that were completely healthy, didn't have any chronic problems, so they wouldn't have been deployed in the first place. So they went over, and yes, they were given contaminated vaccines, and that's probably how they got their Mycoplasma fermentans. And then because of other exposures, environmental exposures, and so on, and also the stress that they were under. And stress is an important factor in here that we really haven't talked about, but that can exacerbate all these problems with chronic illness. And people are under a lot of stress. They're the ones that generally go downhill. So they were under stress. They had these infections already that they were already carrying when they were over there. They had environmental exposures. They had a number of things. And so when they came back, they slowly became ill. But their primary problem initially was this, I believe, this Mycoplasma fermentans. And so by solving that primary problem, at least on a number of patients, we were able to solve that problem. They were able to fully recover. Their family members were able to fully recover. And so we could stop that in its track. But as time goes on, and I've dealt with these veterans now for the last 20-something years, their illnesses have become more complex. It's not just the Mycoplasma now, it's also a number of other factors as well. So if you extrapolate that to the population in general that has chronic illness, these chronic illnesses didn't happen overnight. These patients developed these chronic illnesses because of a number of different insults over time, some of them environmental, some of them, for example, chemical, some of them biological, some of them infectious, some of them not, some of them toxin related, some of them not. But as time goes on, we end up with this complex toxic mix of different environmental problems and infectious problems. And these people are the ones that are the sickest, the ones that are most difficult to treat, the ones that don't respond to any given treatment that well. It's because there's all these other things going on at the same time. And so those are the patients that are really difficult. And we were lucky with the Gulf War veterans that their primary problem was the Mycoplasma. And once we treated that, and if we got it soon enough, those people recovered. But 20 years later, if we got those patients, now they had all these other kinds of problems as well. It's not so simple anymore. You can't just give them doxycycline and see them recover like we did with the first veterans that we dealt with. Now they're much sicker. They've got all these other problems. They've got other infections. They've got other environmental exposures and so on to deal with. And so now it's much more difficult. So now when I'm dealing with these veterans, they have all these other problems as well that we have to consider. So it's become much more complex. So now let's look at civilians who have really, when they come in finally, if you have a chronic illness, often people wait until they're really sick before they see a physician that knows what they're doing in terms of environmental illnesses. And by then it's become really complex. It's become really difficult. And often they go to a specialist who specializes in a given area, like biological toxins or like infections or whatever, and they don't consider the other things that are going on. So it's quite difficult to deal with these patients, and you have to keep an open mind.
Well, wasn't the Huntsville, Texas prison experiment a clear case of some overwhelming factor moving in and spreading out from just this one particular experiment that was being done?
Yes, it was. And of course, those patients that we got the antibiotic to all recovered. And that was the good news. Even these younger patients that had Lou Gehrig's diagnoses, and this is fantastic because, and most neurologists won't believe it, but in fact, the Baylor College of Medicine Department of Neurology proved that these patients were really Lou Gehrig's or amyotrophic lateral sclerosis patients. And they had mycoplasma, very high levels of mycoplasma fermentans in this case. And by treating that, most of the patients that we dealt with recovered fully. They were young, they were healthy, they didn't have a lot of other chronic exposures that were tearing them down. Once we got the mycoplasma under control, they actually recovered from Lou Gehrig's disease, went on to lead normal lives. And I have a number of different, for example, women that were in teenagers that had this, they recovered, they went on to lead normal lives, they had normal full-term offspring, their children were healthy, they went on, they're continuing their lives, they're now middle-aged, and they're doing fine. There's no health problem, no lingering health problems from that experience.
And I take this protocol was the pulse doxycycline protocol.
Yes, this was both pulse and continuous, either one were successful. It turns out the important thing was to do it long enough. So this, because Mycoplasma are very slow growing microorganisms, you can't just give a couple weeks treatment and expect to do anything. Yeah, you can see a little improvement in signs and symptoms, but then it comes right back with a flurry. They have to be treated long-term. They're slow-growing intracellular infections that are not very sensitive to begin with. So patients have to be treated long-term, and they have to be treated slowly with antibiotics like doxycycline, azithromycin, and other antibiotics. And I've published protocols for doing this over the years, and it's all on my website, www.immed.org. That's a website for the Institute for Molecular Medicine, which is a nonprofit that I formed after the Gulf War to help deal with this problem of veterans. So people can go on that website, they can look under treatment considerations, they can find various documents concerning contamination, concerning infections, concerning generally chronic illnesses, basically, and how they might be able to deal with at least some of the problems associated with them. And of course, along with that is membrane lipid replacement, which I'm now working, even as a retiree, I'm working full-time on. And this is, again, the way to supplement your glycerophospholipids to repair the damage to your mitochondria, your cell membrane, and in the process decontaminate your body if you take it long enough and high enough dose. So these problems have been fun to work on. We've had a lot of success in dealing with chronically ill patients and helping them with their problems, and it's been a good ride.
Right. As Mycoplasma is an intracellular infection, could this possibly be fooling a lot of doctors into thinking they're looking at a viral disease rather than a bacterial?
Eventually, you know, when some of these species of Mycoplasma, like Mycoplasma fermentans, were first discovered, they thought that they were dealing with viruses because they were small. They acted like viruses in terms of their isolation. And it wasn't until they figured out that, hey, these are actually bacteria. They have bacterial genes. They have ribosomes. They have all the things that bacteria have. They must be bacteria and not viruses. So yes, they're small. They're intracellular. They get inside organelles, even in the nucleus, for example, where they cause major havoc by producing reactive oxygen species that can mutate DNA and so on. So they cause a lot of problems and havoc in cells. In our mitochondria and other organelles in cells are interfered with because of oxidative free radical damage produced by the Mycoplasma. So they cause a lot of problems. They're hard to find. Detection is a major problem because they're inside cells. Because of that, they're hard to find. You can't just take a serum sample and find them. You can't, it's very hard even in a blood sample to find them. You have to isolate the leukocytes, the white blood cells. You find them inside the white blood cells of a blood sample, and hardly anybody bothers to isolate the leukocytes when they have a sample of blood they're using to do some diagnostic test. But we found over the years that these are all important things that you have to do to find it.
This sounds like it would be an absolute natural explanation for Lyme disease treatment failures.
Well, we think that I work with Dr. Horowitz on some of these problems, and he's well aware of the Mycoplasma problem, and he's well aware of the failures and why they could happen. They could happen for a number of reasons, this being one of them.
Interesting. Well, as I mentioned with Dr. Stephen Strauss, he actually went and investigated the Huntsville prison incident. And for some reason, he didn't attach importance to it. And by failing to attach importance to it, sort of sent a message that it wasn't important. When the circumstances of this incident are still unexplained and should very much call attention to the potential for this kind of infectious process.
Well, I've always faced those problems, and a lot of it is due to the active misinformation about these infections. And there was a problem in terms of the Mycoplasma. It has a kind of a checkered history. It may have been originally developed as an incapacitating biological warfare agent. And because of that, there's really a strong impetus in the Department of Defense and in the NIH and other places to downplay it, to actually, if not outright hide it, to just create enough question about it to whether it's important or not so that people discount it. And that's been the problem I faced all along.
Yeah, if we can clear up a little confusion about Mycoplasma fermentants, there was some speculation that since defense pathologist Shai-Ching Lo owned the patent on it, that he had actually invented this thing, or perhaps done HIV insertions into it, when, as far as I can tell, he simply described it. And what he was describing was the base fermentants and not a modified one that had been developed for biological warfare.
That's absolutely correct. And there's been so much misinformation about this, and you're one of the few people that can understand what possibly happened in there. Because in some of the Gulf War veterans that we examined, when we started to look at detail, because these people were coming back, and there were some of them, not all of them, some of them were getting false positive HIV tests. And they didn't have HIV, they didn't have the virus, that was clear. And we took a small number of these patients, and we started looking at this in detail. And when we looked at it in detail, what we found was, well, they didn't have HIV polymerase. They didn't have other HIV genes that are absolutely necessary to have an HIV virus. The only thing they had was parts of the envelope gene. So why would, and they had the mycoplasma. So why would this be so important? And one of the things we were thinking of, well, it's because they probably spliced in part of the envelope gene from HIV into the mycoplasma to improve its pathogenicity, to improve its ability to enter cells using that receptor that the HIV uses, the same receptor. And so you can get a much easier infectious process, and it also much more pathogenic because of that. So that's what we think happened, but there's been a tremendous amount of disinformation and outright lying going on to protect those facts, because it's just a very embarrassing and difficult question to face head on.
I think your treatment for addressing mitochondrial dysfunction by strengthening the membrane is probably the most logical approach for these complex illnesses that I've seen so far.
Well, the reason it's important is the mitochondrial function goes across all these different aspects of chronic illness. So it's something we have to address. We can't ignore it. Even if we can treat a given cause, we still have to deal with that. You still have to deal with the loss of mitochondrial function, and that affects recovery, that affects normal health, that affects mental problems, everything across the board. You've got to deal with that. So that's one of the things that I realized early on, that we had mitochondrial function problems that we had to address, and how to do that. And so it turns out this was the simplest way to do that, was to repair the lipids, help restore the transmembrane potential, and because of that, restore the production of ATP and help solve some of that problem. It's not the whole thing, but it's an important element of it. It's an important piece of the problem.
It strikes me as being very similar to the reasoning of Dr. Robert Cathcart, the vitamin C enthusiast, who said that high application or taking vitamin C to bowel tolerance was actually helping the Krebs cycle by replenishing the spent electrons that were depleted by oxidative processes. So this seems to be what you're doing, is strengthening the mitochondrial membrane, whereas his goal was to resupply the mitochondria with spent electrons.
Yeah, it's a different approach. And I like my approach better because it actually returns function to, rather than trying to patch it up, it actually repairs it. And there are other functions of mitochondria besides just producing energy. Mitochondria are involved in very complex natural immunity functions. They're involved in cell death. They're involved in a whole number of other processes. So if you let mitochondria get out of control, you can turn on death cycles, you can turn on inflammasomes, you can turn on all kinds of other problems that mitochondria are central to. And so we're not only dealing with energy problems here, we're dealing with a host of problems that the mitochondria have evolved in our system, and we've incorporated them in to deal with a number of other issues, including natural immunity, including cell death, including other issues as well. So the nice thing about repairing mitochondrial membranes is you can deal with all that with just once you return the membrane function to a normal state, you can return those mitochondria to normal function.
Well, fantastic, and thank you very much for your work.
Well, I appreciate the comments, and again, we're still trying to convince people, but the more and more people that take the anti-factor lipids, the easier it is to convince them.
Okay, I wonder if Alicia or Keely have any questions.
I do. You made a statement earlier about a mycoplasma actually. Sorry, I lost my train of thought. I'm recovering from COVID, by the way. And so you mentioned earlier about a mycoplasma actually being involved in the COVID process, maybe people dying from it. Mycoplasma could be associated.
There's probably a small number of patients overall, but it's a sizable amount that progress very rapidly and die very quickly of COVID. And they have extreme inflammatory responses. They have all the other problems. And when you think about it, mycoplasma cause those same responses in patients. And they also, if they get in there, they interfere with mitochondrial function, and there are all kinds of other secondary events that are important to survival that are intertwined with that. So we've seen this in a number of different illnesses, not only COVID, but in cases of lethal chronic fatigue syndrome, for example. There are some cases of chronic fatigue syndrome that go through a lethal degenerative process. And we've looked at a few of those patients, and 100% of them have mycoplasma, so it's important there. In fibromyalgia patients, for example, it's important. These are patients that have some of the highest frequencies of mycoplasmal infections that we've seen in any chronic illness patients. So people with widespread pain tend to have these infections, and they tend to have mitochondrial function problems, and their nerves are going nuts because of it. And so these are issues that we think we have solutions for, but they're not simple solutions. They're difficult problems. They're hard to work with, but they can be solved.
Well, that's good to know. My mother-in-law just died in the hospital with COVID, and I asked the infectious disease doctor to run a mycoplasma panel on her, and also to look at valley fever, aspergillosis, and they refused. And so, yeah, and I also went to, because I'm okay, I'm doing fine physically, but I went to my doctor and I said, can I check for other underlying issues? And she also refused. And so what Keely had mentioned to me earlier in a private conversation, thank you for that.
These glycerophospholipids
fantastic,
really help you with long COVID. That's one of the things that I'm interested in, by the way.
Oh, wow. That's great.
Long COVID involves damage to your nerves and damage to your cells. And it's one of the things that happens is that your membranes get damaged to the excess free radicals that happen during the acute illness phases. There's a lot of free radicals. There's a lot of damage to very sensitive membrane structures, and so you've got to repair that. So that should be an important part of anybody's long COVID therapy.
Yes, absolutely. I take my high dose phosphatidylcholine and my cod liver, take about 4 tablespoons per day. And that seemed to really get me out of COVID along with.
Well, that's important. Those are important sources as well of the glycerophospholipids. And again, I'm not trying to push any given product. We just happen to do clinical trials using this particular product.
Yeah, no, that's totally great.
To do it. And without that, we couldn't do anything. So,
Yeah, I just had a question in your treating journey. So you add the phospholipids. It seems like you do the pulsed doxycycline. Do you add in any other factors like enzymes to destroy the cell wall? And also,
yeah,
why doxy and not an antifungal for a mycoplasma infection?
well, for one thing, it's they're very responsive to doxycycline, so that's important. Uh, there are fungal issues with things like chronic fatigue syndrome, and I discuss that in some of my treatment materials as well, because those fungal issues can keep people sick. They won't recover unless they address that. And the same thing that people that are treating only their fungal diseases and have things like mycoplasma, they're not going to recover unless they deal with the mycoplasma. So as I was saying before, you've got these number of different issues, and you can't just deal with one of them. You've got to deal with all the issues that are causing toxic events to occur in your cells. And unless you do that, the chances of recovering are reduced. And they keep going down further and further and further, the more of these issues you have. So I know it sounds complicated. I know it sounds, difficult because you're dealing with your GP or family physician, and they don't want to hear about it. They want to know, okay, if there's one thing, if there's one prescription, that's what they want to deal with. They'll give you that one prescription, but they won't deal with all this other stuff. It's just too complicated, too complex. They just don't want to deal with that. So we've tried to inform patients that, okay, they don't want to deal with it. You're going to have to deal with it. You're going to have to take things in your own hands to recover. So if you look on my website and you look under treatment considerations, there's some documents there that go through a whole thing, everything from immunomodulators to antifungals to membrane lipid replacement to antibiotics to nutrition. By the way, I don't want to pass over nutrition because this is the one thing you're using. And we tell patients, look, until you correct your nutrition, you're not going to recover, period. Even if you could temporarily recover, you're going to fall right back again. You've got to deal with the nutritional problems that you have as a patient. And so we deal with nutrition. I've written articles just on nutrition alone and so on. And so there's all sorts of things. There's vitamins, there's minerals, there's supplements, there's all sorts of different things to deal with. And you have to put those all in perspective, and you have to begin to think about all these different multiple things that you have to deal with a chronic illness, because your illness is complex, and until you take a multifaceted approach, you're just not going to recover. And that's sort of what we've seen.
Thank you for that, Dr. Nicolson. I just had one quick question before I move on to Keely. Would you be willing to raffle off one of the NTF factor medications that you are advertising?
Sure. You want me to donate a bottle? Is that what you're asking?
Yeah, would that be okay just for our audience members?
Sure.
Okay.
Yeah, I'll donate a bottle to you. Just email me the address where to send it.
Sure. Thank you so much.
Loose bottles hanging around. So
cool. Awesome. Thank you.
Normally we don't work that way. And a lot of the patients that are really sick, of course, it comes in a number of different forms, but the ones that are really sick and require, pretty high doses, we generally go to the powder, because the powder is colorless, odorless, tasteless, and you just put a few scoops of the anti-factor in any food or any other supplement that you're taking. And it's very easy to take that way and doesn't interfere with anything else that you're taking. So for patients that are really sick, we recommend going to the powder, because there they can take the 4 to 6 grams per day that's necessary for their particular illness. So for patients, for example, that are chemically exposed or environmental toxin exposed, so this could be mold toxin exposure, for example. If they want to do something about that, then they've got to really jam their system up with the anti-factor lipids. So they've got to really take use of this bulk flow concept to remove slowly those toxic molecules. By the way, there's a real advantage of slowly removing toxic molecules like mold toxins or bacterial toxins, because if you remove them too quickly, people get severely sick. They really show severe symptoms of poisoning, whether it's mold poisoning or bacterial toxin poisoning. So how do you get around that? You do it slowly. So we've had patients, for example, that it's taken a year for them to slowly deplete toxic molecules from their body. But during that year period, they've not experienced sicknesses or severe symptoms that they get if they try and remove them too quickly. So slow's better. Slow and steady. That's what we try and tell people. You want to slowly recover from these illnesses. You don't want to try and quickly recover, because if you quickly recover, you're going to rebound right back again.
Dr. Nicholson, I do have a couple of questions for you. My first question is, does your stepdaughter still currently have any symptoms of Gulf War syndrome or no residual chemical sensitivities? No. Okay, and the other question I had is, you mentioned that some mycoplasma are naturally occurring in the body. Could that extend to other forms of mycoplasma, or is it definite that some are completely foreign and not natural to the body? Because the reason I asked that question is I want to know if this could indicate that a weakened immune system is letting mycoplasma that might naturally occur.
Well, that happens, yeah. But now consider that there's some 150 different species of mycoplasma. So there's a small number that are known proven pathogens in humans. There's a half dozen or 10 maybe that are known to be pathogenic in humans. And generally, these are also pathogenic in animals. Although in animals, there seems to be a wider spread of different mycoplasma species that are pathogenic. So if you look at a given animal, like a pig, for example, there's certain species of mycoplasma that cause disease in pigs. And when you look at the types of mycoplasmal infections, generally, again, you're down to less than a half a dozen that are primarily important in the pig. But they're different species from what we have in humans. There's some overlap, but in general, the ones that are the most pathogenic in pigs are not the species that are most pathogenic in humans. And the same thing is true with cattle. So you look at cows, and mycoplasma is a major problem in things like pigs and cows and horses and so on. But if you look at cows, again, there's certain species that are predominant pathogens in cows. They're not the species that are predominant pathogens in humans. So in humans, we have this six or eight species, primarily things like Mycoplasma pneumoniae, Mycoplasma fermentans, Mycoplasma genitalium, so on and so forth. These are the ones that are pathogenic in humans. They can be pathogenic in animals. Generally, if they're pathogenic in animals, we find them in pets of humans who are sick with the mycoplasma. So we can pass them back and forth between our pets and us, the species that are predominantly pathogenic in humans. And so we've seen this in pets. And can pets become sick? Yeah, they can. Or they not. They can carry the human pathogen without even showing symptoms and then spread it back to another human. So this is some of the complications of dealing with this. We don't know, for example, about the prominent mycoplasma species of pigs, for example, if they can infect humans. I think it may in rare cases happen, but generally it doesn't happen. So if you look at the oral cavity of humans, are there mycoplasma? Yes, there are. You can find species of mycoplasma in the oral cavity of humans, part of our normal flora. And do these cause disease in humans? No, they don't seem to be. And so we can have benign species of mycoplasma that don't cause disease, or we can have pathogenic species of mycoplasma that cause disease, but only when they penetrate into the blood and get into our cells and get into our tissues. We can have even those pathogenic forms superficially in our oral cavities and not be sick. So this is one of the confusing things that confuses practitioners to no end.
So it sounds like it depends on whether or not it crosses the blood-brain barrier.
Well, it crosses at least the blood barrier. If it crosses the blood-brain barrier, which they can do, that's an added difficulty, an added problem. But generally, these things start by crossing the blood barrier, either in the lymphatics and cross into the blood, for example, or directly because of a wound or whatever. And when they're in the blood, they're susceptible to being picked up by just normal leukocytes and monocytes in the blood will pick them up and eventually destroy them. their own hydrogen peroxide systems for destroying pathogens like this. But if they get in high enough content, they can escape this. They can find their way to cells and get engulfed into cells. And there they can slowly but surely cause problems. They can slowly divide, maybe take over mitochondria, take over other organelles in the cell, and cause real problems. So these infections don't occur quickly, although certain illnesses like childhood atypical pneumonia can occur pretty quickly. In general, they're slow. So you get the illness slowly, you get the signs and symptoms develop slowly, and when they're treated, if they're treated successfully, they slowly go away. They don't just go away overnight. So it's a long, slow process.
Thank you, Dr. Nicolson. The last question I have is just in terms of treatments for mycoplasma that might extend outside of the category of antibacterials, or antibiotics. I'm just wondering if you have any insights or opinions on the use of maybe like herbal medicines that are antibacterial for mycoplasma, or even something that's a mainstream pharmaceutical like an ion channel medication?
Yeah, sure. And in fact, I published a review that covers all the alternative and conventional therapies of mycoplasma. You can go on our website and you can download it. It's published in the International Journal of Clinical Medicine. And it's a pretty comprehensive review on all the what we consider to be conventional approaches, like antibiotics, for example, or other approaches using drugs, or unconventional, using different herbs, for example, herbal approaches and other things. So it's covered there, as well as support systems like membrane lipid replacement is a support system, which should be used during any type of infectious process. These are sorts of things which are covered in the review. So people can download that. They can find it very easily on our website.
Thank you for explaining that. We will get a copy of that and we will post it with this episode so that people can.
Sure, I'll send you a copy.
I would love that. Thank you.
It's an open access publication, so you're free to use it.
Thank you so much. Thank you for your time, Dr. Nicolson.
Okay, good luck.
Perfect. Thank you so much. For your intro, I'm not sure if you sent me your bio or not, but I'll reach out to get your bio because I will.
Well, you want a brief, just a brief bio? You don't want my CV. That's about 80 pages.
Yeah, just a brief bio to
publications. I don't think you're going to go through 700 publications. So,
oh man, no.
I'll just send you a brief bio. It's less than a page. Just
sure.
a few of the highlights.
Yes, just the highlights so I can introduce you properly.
Okay, no problem.
Great. Thank you so much.
Bye.
Bye. Let me just record the outro real quick. Thank you everyone for joining us today. It was a wonderful conversation with Dr. Garth Nicolson on mycoplasma and how mycoplasma are also involved in a lot of other common infections that we're seeing these days, like Lyme disease, autism, ALS. Very, very interesting. And as he also mentioned, COVID could also have a mycoplasma component. Good luck getting a test for it because I sure wasn't successful. Anyways, thank you again, everyone, for joining us. And please like, share, comment on our content. Also support our podcast by donating to our GoFundMe and Patreon page. Thank you so much. We'll see you next time.